This is a continuation of our video on the remainder and factor theorem. I'm going to do a little review with this problem right here. If you're asked to solve this equation, this is old stuff right here. The best way to solve this equation would be to factor it. And it factors as x minus 2 times x plus 1 equals 0. Recall the terminology. These are called factors. X minus 2, x plus 1, they are factors. If we continue solving, set this equal to 0, set this equal to 0. We have x minus 2 equals 0, x plus 1 equals 0. Solve and we get x equals 2, and we get x equals negative 1. These are solutions. They are zeros, or they are also known as roots. There is a definite relationship between a factor and a root. The factor has got the x part with it. The root is just the number. That's pretty easy to solve by factoring. We had x squared, we had two factors, we got two zeros. Well, if I ask you to solve this equation right here, you are probably stumped because it's x cubed. We have solved some with x cubed in it, but those were ones that we could take out of GCF and then factor from there. There is no GCF here. There is no factor by grouping we can do here, so basically we're stumped. Well, we're eventually going to be able to solve a problem like this from scratch. But before we get there, we are going to do this. We're going to solve the equation given that 3 is a zero of the function. We're told that 3 is going to be one of the zeros. What we want to do is find the other ones. Since we know that 3 is a zero of the function, we're going to use 3 kind of like a key to unlock the door. 3 is going to get us started. So we're going to do our synthetic division using those coefficients with 3. Bring down your 2. 3 times 2 is 6. Add and get 3. 3 times 3 is 9, gives me negative 2. 3 times negative 2 is negative 6, which gives me 0, which verifies that 3 truly was a 0. Take a look at those coefficients. Those coefficients stand for 2x squared plus 3x minus 2. Now I'm going to set that equal to 0 and just use that line. What I want to do is solve that. Can you solve a quadratic equation like that? Yes. If it has x squared in it, you have the option of perhaps factoring it, or you could use the quadratic formula on it. I don't need to use the quadratic on this one because this one does factor. So I'll do 2x and x in the front because that's what multiplies to give me 2x squared. Because this last sign is negative, I know my signs are different. And the only thing that multiplies to give me 2 is 1 and 2, and this is the way they get placed. If you need some factoring help, go back and look at the videos on factoring. This does give me a positive 3x in the middle, so I know I factored it correctly. These right here are the other two factors, but we want to solve the equation. So set these two things equal to 0 and solve. 2x minus 1 equals 0, and x plus 2 equals 0. This one's real easy. Subtract 2 from both sides, so we get another 0 of negative 2. Add 1 to both sides here will give me 2x equals 1. Divide by 2, and I get x equals a half. So my 3 zeros are the 3 I was given initially, and these two other ones I found by factoring the depressed equation. So that this number right here that you were given unlocks the door, gives you a quadratic equation that you know how to solve. So that's how we're going to solve this kind of problem. I want to show you something on the next screen with a graph just to emphasize what these numbers are. Remember, these are called zeros. These are where the graph will cross the x-axis. So take a look at the graph. I had to do a little bit of faking here because it went off the screen, but those numbers don't really matter. What matters are my 3 zeros. Negative 2 was one of my zeros, 3 was one of my zeros, and 1/2 was one of my zeros, and that is where the graph crosses the x-axis. There are 3 of those zeros because this was x cubed, and you should recall from the graphing videos that if it's x cubed, it has a chance of crossing 3 times, and it does on this one. Same set of directions. This time we have negative 1 being a 0, so let's do negative 1 with 15, 14, negative 3, and negative 2, and then start our synthetic. Notice I'm not changing that sign. Whatever number I'm given goes in the box. There is no sign change with that. Negative 1 times 15 is negative 15. Add and get negative 1. Negative 1 times negative 1 is 1. Add and get negative 2. Negative 1 times negative 2 is positive 2, which gives me 0, which verifies that that truly is a 0. If you're told this number is a 0, and you get a remainder over here, you've done something wrong with your arithmetic. Maybe you copied this down wrong, you didn't have the correct signs, but this better turn out to be a 0. Let's fill in our x's, which is this polynomial solve. 15x squared minus x minus 2. Most probably to factor 15 will be 5x and 3x. And since this last sign is negative, my signs are minus and a plus. And the only thing that multiplies to give me 2 is 2 and 1, and it's going to have to go here. Because if I FOIL this out, that's what's going to give me negative x in the middle. Set these equal to 0 and solve. 5x minus 2 equals 0. 3x plus 1 equals 0. Solve each of these, subtract 1 from both sides, and divide by 3 will give me negative 1/3. Add 2 to both sides and divide will give me positive 2/5. This one I didn't graph because of the fractions, they're just harder to find. So we have totally solved the equation. The 3 zeros are negative 1, which you were given initially, and then these two we found by factoring this. There are times you will have a polynomial here that does not factor, and then you have to use the quadratic formula. That's going to happen in the next video. Now, sometimes the directions are a little bit different, but it's asking you to do the same thing. It says use synthetic division to divide this out, and then use the result to find all the zeros of the function. Same deal. However, because this is the factor x plus 1, this is where I need to do my sign change. Negative 1, and then fill in my other signs here. Start my synthetic. Negative 1 times 1 is negative 1. Add and get negative 3. Negative 1 times negative 3 is 3. Add and get 2. Negative 1 times 2 is negative 2. Gives me 0. Yippee. It does verify that that was a 0. Put your variables in, and then solve this equation. And this will factor as x minus 2 times x minus 1, a little bit easier to factor than the last one. Set these each equal to 0, and you're going to get 2 and 1 as your other solutions. So you have 3 solutions, or 3 zeros. The negative 1 we knew initially, and these 2 that we found by doing synthetic division and continuing with the factoring.